This video is about index laws. We're going to start by looking at multiplying and dividing indices with the same base. Let's say we have 2 to the power of 3 multiplied by 2 to the power of 5. What does this look like in expanded form? Well, 2 to the power of 3 is 2 times 2 times 2. And then we're going to multiply that by 2 to the power of 5, which is 2 times 2 times 2 times 2 times 2. So all of this together will become 2 to the power of 8. And you'll probably notice that 8 is the sum of 5 and 3. So let's write this as a general rule. We can say that a to the power of m multiplied by a to the power of n becomes a to the power of m plus n. What about division? Let's say we have 6 to the power of 8 divided by 6 to the power of 6. Now what I'm going to do here is I'm going to write these in expanded form, and I'm going to use a division line instead of a fraction sign. So we've got up the top 6 times 6 times 6. Okay, 8 times, and then down the bottom we've got 6 times of 6. All right, and we can see that because only multiplications are occurring, we can cancel these 6's out. So what do we have left? Up the top, we can see we've got 6 times 6, and we have nothing left down the bottom. So we could write over 1, but I'm not going to worry about that. So 6 times 6 is 6 squared. Once again, let's write this as a general rule. We can say that if we have a to the power of m over a to the power of n, that becomes a to the power of m minus n. Let's do some more examples. In this first case, we can see that the base is the same. We've got 2 bases of 3. So we can rewrite this as 3 to the power of 6 plus 4 because it's a multiplication, which becomes 3 to the power of 10. In this case, we can see that the bases are the same and a division is occurring. So we can write this as 7 to the power of 9 minus 5, which is equal to 7 to the power of 4. In this case, we've got a similar thing to our first example. However, we've got variables instead of numbers as the basis. So x to the power of 4 plus 5 is equal to x to the power of 9. And here, the one thing we need to consider is that we can only add the indices when the bases are the same. So we're going to treat the x bases and the y bases as 2 separate objects. So x to the power of 3 plus 2, y to the power of 4 plus 1. What we end up with is x to the power of 5, y to the power of 5. Let's look at some examples that involve a couple more steps. In this case, we can see that the base is the same for each indice that we've got here. So we're going to start with an addition. So we've got 2 plus 3, and then a subtraction, minus 4. So we end up with 2 plus 3 is 5, minus 4 is 1. But we don't write the 1 here, so we're just going to write x. In our second example, I'm going to start by just looking at the numerator and worrying about the denominator later. Now, when you have numbers in front of the base, you can just treat them as normal numbers. So I'm going to start by multiplying 2 by 8. So 2 times 8 is 16. And then we have a to the power of 3 plus 2, b to the power of 1 plus 3, all over 4a 4b squared. So this will become 16a to the power of 5, b to the power of 4, all over 4a 4b squared. Now, once again, we can just treat these numbers as regular numbers, and it's a division happening here. So 16 divided by 4 becomes 4. And then we have a to the power of 5 minus 4, b to the power of 4 minus 2. So our final answer is 4. A to the power of 5 minus 4 is 1, and I'm not going to worry about writing that one. And then b, 4 minus 2, becomes 2.